Howdy PreCal, it is Ms. Kosh. I am making a video today to show you a few different calculator strategies for our last test of the year. And so our last test will cover series, vectors, and parametric, none of which are on the AP exam, but all of which are relevant to other courses. So either to BC Calc or to physics or whatever. So I have here a CASIO and a TI, and we'll see what we can do. I'm going to do the series part first, and if you're getting ready for our series quiz, you can stop the video here and then come back and watch the rest after we do vectors and parametric. Okay, that's the plan at least. Let's see what happens. So here, both calculators have been cleared the way that I expect you to have them cleared. And when you come back to the main world, there's actually sigma notation on the calculator. So in the CASIO, you would go math, and you could come over here, and there is sigma. The thing that's different about what we usually do, when we write these problems just in general, we tend to use the sum as n goes from 1 to, I don't know, let's say 100 of, this one I'll make arithmetic, 7n minus 1. I don't know, I just made something up. We tend to use n or k or I, maybe j. We could use within reason, any letter we want to. But in the calculator, we need to use x. But for whatever reason, we don't use x when we write it. But the calculator does use x. So what we have here, let's see if I can zoom in a little. Oh, what did I type in? Okay, let's zoom in so you can see my screens a little bit better. There, does that help? So I went to, just a reminder, when it was here, I went math and then over, and there's that summation. And so it was 7x minus 1. Well, I had written 7n minus 1. Then I can come over, and I want x to go from 1 to, I said 100. Okay, and there is the sum. If you remember, what's my formula? My formula is the number of terms over 2 times, we can either find the first term, plug in 1, I get 6, plus plug in 100, I get 700 minus 1 is 699, and that should match that previous number, which it did. That's a good sign. Okay, on the TI, I used to be an expert at TI, and now I'm a little out of practice, but we go to, I saw it a minute ago, math, and then we can come down here to there's summation. I think it's letter O or number 0. And so here when you type in x goes from 1 to 100 of 7x minus, I said minus, delete, minus 1. And that should equal the same number. I think we do see that they're the same. 35,250. And there we go. So there is the summation notation. Now, granted, I am well aware that the calculator can do this. And so when I give you a calculator and let you take this test, I will make it so you have to know enough. You have to know more than just how to type it in your calculator. But you can use this to check. For example, instead of writing out this particular problem, I might have said, find the sum what is it, 6 plus 13 plus 20 plus, I might have said plus ... plus 699, and I would have only given you this part. Well, if I give you this, you have to know, first of all, what type of series it is. You have to know then how to find, even if you just want to plug it in the calculator and not use the formulas, you still have to figure out how to turn this series into summation notation. You have to figure out what term is this actually. And so I'll just show you real fast how to do that. I recognize that my common difference is 7, and so I have a sub n is equal to a sub 1 plus n minus 1 times d. Remember, I'm not giving you this formula because this part is fair game for the AP Pre-Cal test, so I'm not going to give you this formula. What would a sub n would be equal to 6 plus n minus 1 times our common difference was 7. I see that a sub n is equal to 7n minus 1. And then, once I have that, then I have to figure out what term this is. So then I can set this equal to 699. Add 1, 7n equals 700, and then n equals 100. Now that I know this, I know my formula here, I know my total number of terms, and I know that I used that first term. I could say, okay, it's the sum as n goes from 1 to 100 of, don't forget the parentheses, 7n minus 1. And now but I notice how much work I had to do in order to find this to plug it in my calculator. So you can use the formulas, or you can do, in any case, this is what I'm going to give you on the test. Okay, so that's what I wanted to show you with the calculators with series. Come back later or keep watching for We'll Talk Vectors. So one of the things that we did with vectors, and now I'm not quite in that headspace yet, so we'll see if I remember everything correctly like I want to show you. We would often have a vector. I might say vector A has the magnitude of vector A. Sometimes in IB we just use one set of lines. In PreCal we tend to use two. The magnitude is equal to, let's come up with the number 25. And then the direction, with the direction of, I don't know, 73 degrees. Whatever. Okay, and then the magnitude of vector B will be equal to 33. I'm making whatever my units are, with a direction of, well, let's say with this one that our direction is 142 degrees. Okay, so now if I want to figure out what's happening so I can rewrite vector A to be and I can rewrite vector B to be 33 cosine, the x value is cosine 142. Hopefully I have other videos where you already understand where this is all coming from. My purpose in this video is to talk calculator. Okay, so in these two, there we go. In these two, I had cleared both of them a few minutes ago. So you may notice that up here it tells me that I'm in radians. It doesn't tell me in the TI, or if it does, I don't know how, but it defaults me back to radians. So I'm going to come down here to degrees, and then here I'm going to come over to setup, and then come down angle to degrees. Okay, so what I like to do for these problems, I probably have a video on this already, but I'm probably not with both of them. Okay, enter or clear. Hopefully that switched. Well, we'll find out if they're not the same. So let's say I'm adding vector A and vector B, and I want to find the new x component. I would take the vector A was 25 cosine 73, plus the vector B, I forgot, 33 cosine 142, and I'm going to store this. So this button right here lets me store this as this is now the x component of my new vector. Okay. And so that's negative, whatever. And then I can do the same idea. Actually, I could come back here and change this, delete to sign, change this, delete to sign, change this. This will now give me my y component. Alpha y is here. Okay, and so this vector is going to have a negative x and a positive y. So we need we're going to be in quadrant 2. Okay, so here on the TI, I think I already changed my mode. We're going to find out. It was 25 cosine of 73, close that parentheses, plus 33 sine of 142, close that parentheses. Store on this calculator is down here where it says stow. We're going to stow that number. Okay, once again as x. Oh, that's different than what I just got. Oh, I see. Do you see my problem? Did you catch it before I did? Quick. Can you catch it? Can you catch it? Does it let me re-enter this? Okay, I'm enter. Oh, there it goes. Will it let me try this again? No. Why won't it let me type over the top of it and correct my mistake? All right. Oh, I can clear out all that kind of stuff. Okay. Let's try that again. I'm so sorry. 25. Got confused over here. Cosine of 30. Nope. 73? No, it was 73. I'm sorry. 25 cosine of 73, close parentheses, plus 33 cosine of 142. This needs to get stored down here as alpha x. That looks familiar. I didn't write it down, but I think that's correct. Okay, 25 sine now of 73, close parentheses, plus 33 sine of 142, close parentheses, we're going to store here as alpha y. Okay, and there's that. So now both of these, I've stored x and y. And so the things that we need to do to find the magnitude of the new vector, we'll take the square root, we'll take the square root of alpha x squared plus alpha y squared. There's the magnitude of the new vector. Same idea here. Square root is that's square root. Alpha x, where's squared, plus alpha y squared. Sorry, I'm slower on the TI than I used to be. Do those match? They sure look like it. Can you see? Hopefully you can. And then we need to do the inverse tangent. So inverse tangent of alpha y over alpha x is that. However, this is in quadrant 4, and we had said a little bit ago that we were in quadrant 2, so normally I would add pi, but now we're in degrees. We're going to add 180. Oh, I'm about to sneeze. Oh. Well, goodness. Okay. Sorry. And so there's that answer. Let's see on the TI. So it's inverse tangent of alpha y divided by alpha x, close parentheses. Here's that. That looks familiar, but now we have to add 180. And so there's those values. And so that's the big takeaway. The big takeaway for me with vectors in the calculator is to store things and hang on and let the calculator hang on to those exact values. Because then that makes it makes everything so much easier. Okay, now I want to talk parametric. And so what we need to do here, and we're going to go menu. We do a lot of graphing with parametric. I may not do everything. So if I go to y equals here on the TI, it just gives me y equals. Well, they both say y equals. On this one, when I want to change, I change the type to parametric right here. And so now it's got these two equations that together are going to make my new first equation. So it's xt1, yt1, xt2, whatever. Over here, in order to do that, I think I have to go mode and then come down to parametric. And then I can go y equals. And now I have the two components for that. So we'll end up seeing stuff like 33x, or now it's t. So cosine of 21 degrees. And then it's negative 16t squared plus 33t sine 21. And if all of this is making no sense, hang tight. Well, I'm going to teach it to you. Plus 4. Let's see if I can remember that when I get over here. 33t. Notice the t on both of these guys with these two buttons. Can you see what I'm pointing to? It's the x comma t comma theta comma n. Is that what that is? X comma theta comma t. Those buttons change depending on what mode you're in. Cosine of 21. And then I said negative 16 t. I'm not quite in this headspace right now, you guys, so hopefully I'm not making any mistakes. I just like, oh, let's do parametric. I think I know what I'm talking about. This one would be sine of, what was my angle? 21 degrees. Close that parentheses, and then I think I said, oh, I forgot, plus 4. Okay, so when I have these two, what I would recommend in both of these is that we go to window. So we're going to come to window right here. And both of these, on this one, on the CASIO, the x comes first and the y comes second, and you scroll down and you can find the t values. On the TI, the t comes first. So this one, and it defaulted here. My default, after I had cleared the calculator, was from 0 to 360 with a PTCH or whatever. But basically, it's a step of 3.6. So what this is going to do is it's going to plug in 0. It's going to plug in 3.6. It's going to plug in 7.2. It's going to plug in, what is that, 10.8. It's adding 3.6 every time. If I leave it here, we are not going to get a very nice, pretty curve. So I would recommend changing this. And it's going to take forever because it's going to plug in all of these values up to 360. Let's change that to 10, and let's change this to 0.1. And that's a good default just in general. Over here, that's 2 pi, and the 360 was also 2 pi, but anyway. I'm going to change this to 10, and I'm going to change this to 0.1. just to match. And then this one is at, well, we'll have to probably change these. My X, I don't know, -10 to 200. I'm just guessing. I don't know. I totally made up numbers. So, and then here, -10 to, let's try this 200 again. So we'll do the same idea. Oh, where's X min? -10 to, I said 200. We're going to come down, -10 to 200. And now I can hit graph here. I can hit exit. I can tell it to draw or hit enter. Okay, my windows weren't great. I didn't know. Let's change this window. We don't need to go to 200. Maybe we just need to go to 50. And that, oh, back to my window. And this 200 was way too big. Let's just say 30. Let's see. Oh, that's much better. And you'll notice, I mean, it's even too high still, but you'll notice that it does look smooth and continuous. If I had not changed my T values, let's go back to window. What did I change this to? No, I don't, 50, and then 30, I don't remember. Graph. Okay, that's pretty similar. The good news, bad news in the TI is that all you can do from here is G-solve. It won't give you root, it won't give you max, it won't give you min. Like you try and click that and it doesn't know what to do. So we can do G-solve. All we can do is YCal. And then you can tell me, I want to know where is it at half a second into the trip. Okay, let's see what the, does this guy calc? Second calc, I think it only gives you that value. And so same idea, you can plug in a particular value. What I typically do with these guys is I would exit out and change the second equation to type to back to y equals. And so the first one, this is one thing where CASIO has an advantage. I can type in the second equation as a rectangular, as a y equals, let's see, sine, what was it, 21, and then I think +4. Okay, and so now when I draw this, it's going to give me, this is as a function of time, and so this is how high is it at a particular point in time, whereas this one is, I'm sitting in the stadium watching the water balloon get tossed. I'm watching the football get kicked. I'm watching whatever, and so I can see how far down the field it is at whatever point. In the TI world, if I remember correctly, if I am wrong on this, let me know. You can't go back to y equals and change the mode on the second one, I don't think. If I change the mode down back here, then I go to y equals, I've lost that first graph. Okay, whereas in my CASIO world, it'll do both for me. So here I'd have to type that back in, and now I can do G-solve. I can find the root. I don't really care about the negative root, but this will tell me the time that it hits the ground. What I do here is I take this back. It remembers the last X. I'm going to store that as alpha G for ground. Okay, and so that's the time it hit, when it hit the ground. I can come back to my and you can do all this stuff in the TI as far as finding the roots and whatever. But let me show you rather than take up any more time. What am I doing? Drawing. Okay, and then I can also do G-solve. I can find G-solve the max. And it's not even trying, it's not even asking me which curve I want to use because it can't do it for the parametric one. It'll only do it for the rectangular one. Okay, so now I can take this and I'm going to take this X and now store that as alpha, where is M? M for max, because I'm real creative. Okay, so now when I come back menu to the graph, I can draw this. Actually, I'm going to turn off, nope, what am I doing? I'm going to turn off this one, so I'm going to unselect it there. Draw, so now there's just the parametric one, and so I can do G-solve, go over to YCal. I want to enter G for ground. And so now it's telling me that at time, what is that, 0.99, whatever. So almost 1 second into the flight, it is 30 feet-ish down the way, and it's 0 feet high. Okay, if I want to do, I can then do G-solve, do that same thing, and now let's use alpha M. And so it's telling me at this time, 0.3695, whatever, it is 11-ish feet down the field, and 6-ish feet high. I think I was all in feet in this. It doesn't really matter. But hopefully, that was a very long video on some calculator stuff, but hopefully that's helpful. All right, like, subscribe, comment, and let me know how I can help you. Good luck. Go practice.